Hey folks, so in this video, I'll introduce different ways to implement a node class. So we already committed to the idea of let's now implement a stack using a list. In order to do that, we need to create nodes, right? Lists are made of nodes. So how do we represent that? Represent it as a class. Obviously, right, there's going to be different ways to do this. So what's the simplest thing I could possibly do? Well, it's the minimalistic one on the top left. So this is my minimalistic node, which has only really 2 lines of code in it. So I have there basically class, node, generics, item, and then 2 things inside. So obviously I have a class called node. It takes in 1 generic because I don't know, right? What am I going to be storing, right? So we already had this discussion with the stack in general. We need to have some way basically to support stacks where it's like, well, I can store different things inside of them, right? And so we need to kind of support the same thing for a list, right? If we're using a list to store stuff that a stack contains, it should make sense that that list needs to contain we need to have some way, right, to support containing different types of things, right? And we'll use the generics feature of Java to do that again. So we have that, and inside we have basically a element and a next, right? Those are our 2 variables, and those 2 variables are being used to store, first of all, the item inside of a particular node, and then a reference to the next thing, right? Where do I go to get more information, right? That's the purpose of my next variable. So this is the simplest thing I could possibly do, right? This is a minimalistic, and it's a decent approach as well. So this is one way we can implement a node. Another way to do it is this kind of monolithic approach. This is, I'm going to maybe label these a little bit. This is maybe something you would see in Java, very typical. There's also another approach which I'm calling the monolithic approach. So the monolithic approach is okay. This is more maybe C, C++ a little bit. Or well, you'll see it more in C and C++, but it's still badly written code maybe. So notice what has happened here is that instead of having this item, my item has gone away, and instead there's 3 other variables there. So actually what this is, right, is it's a linked list node where I'm just kind of baking in the pieces of data that I want to be in there, right? So rather than leaving a placeholder, rather than leaving a generic, I'm just directly putting things in there, right? So people kind of just combine them all together. You have this one class which has all your data directly, and then a next pointer, right, or a next reference. So this is going to would be typical, right, maybe in C or C++. For us, we will try not to work with it with something that looks like this because it is a little bit harder to maintain. Right. Another approach which is more OP and maybe well, you'll see it in places. It's sometimes good, sometimes bad. It's basically an object-oriented approach where you have, or an inheritance approach, maybe it would be a more accurate thing to say. Some sort of a base class called node, which has basically a reference to go forward to go find more stuff, and then a child of that has basically the data added in, right? So I have here this class person node, and class person node extends node, right? So I get to borrow all the stuff in node and then add my own stuff as well. So node itself, right, has the next pointer, right? It has a way for me, next reference, has a way for me to get to the next thing. But then in person node, right, that's when I add on my data. And you can notice that this looks maybe a little bit similar to the contact node on the left that I said was a monolithic design. But here things are nicer because they're separated out, right? I have the parent, I have the child. And that data, right, is just encapsulated inside of the child, right? So this might be a better approach. As a final note, you won't always really have a choice when you do this. Usually what you're going to end up using, right, usually what is the best thing, is whatever your standard library uses, right? So when you go to implement stuff, right, in the field, you're going to have already, probably some library that's out there that already implements linked lists for you. They're going to already have a node class. Whatever it is that they give you, you're probably just going to use that, right? Because it already exists, it's already been debugged, it's already good to go, right? So you may want to look at whatever libraries are available, right? Once you get out kind of outside of this class, right? I mean, right now for this class, I'd expect you guys implement this stuff from scratch. Once you're outside, you can start looking at what's already there, right? And maybe using that stuff instead of creating your own. Okay, so let's kind of put together some ideas here. Let's implement a node for our linked stack that takes kind of a minimalist approach, but has maybe a little bit feel of being better engineered than what I have up here. So this is my linear node class, right? So this is going to be what we're going to use to build our singly linked lists, right? So here we're trying to introduce, right, is the idea of a list that has basically one reference to things that go after it, right? So this is a singly linked list. This is what we're implementing in this code here. There is obviously another version as well called a doubly linked list, which basically has additional arrows to lead us backward in this chain. Now, we're not going to worry about that in this video. For now, though, we'll just stick with a singly linked list. So initially I have kind of this thing here that I'm trying to build. So I have basically my 2 member variables inside. I have my data, I have my element, and then I have my next, right? I have those 2 different things. And what's really different here, right, basically is that I've done a little bit of more of an engineering approach, right, or a little bit of a more maintainable approach. And I have the accessors, right? So I have get element, set element, right? Get next, set next, right? I have those. Then of course I have a couple of constructors. I have constructors that will properly initialize things, will set stuff to null when it needs to be null, et cetera, et cetera. So these are all kind of very typical things that I would have, right? So we're not going to be so simple as, to just have the 2 lines in there and the things is public. We're going to add the appropriate wrappers around them, just so it, it looks a little bit nicer. It's maybe a little bit more reliable. Now, as a general note here, right, you should be a little bit aware, right, that it is, well, so sometimes it's good to have these kind of helper wrapper functions. Sometimes it isn't, right? So here it maybe is a little bit more work than we need to do. Because it's really simple, right? Notice that we're just returning it, that we're just assigning it, right? There's nothing really complex happening there. Typically where you really need getter and setter methods is when you are looking at something where it's like, well, there's a lot of work to do, right? I just can't allow it directly. I got to do some stuff, right? I got to prepare things. I want to do error checking. I want to see if this is set up right, that type of deal, right? That's the thing you would need this for, right? For a simpler case like this, I mean, this is pretty much on the edge of, do I need accessors or mutators as methods, right? Or can I just leave the functions in there by themselves? Now for us, we just want to introduce good practices. So we're going to stick with it, having it here with, all those accessor methods, mutator methods, so that we just have, a pretty nice looking solution that's, decently well engineered. All right, so that's it for our node. Now we can start thinking about how to actually implement our list into our stack that we've been already discussing.